call is now being recorded.
Hello, everyone. So, we will be starting this session in 5 minutes as I'm expecting some more students to join. Just wait for 2 to 3 minutes. I will be starting soon as I'm expecting some more students to join. So, in 2 to 3 minutes, we will be starting. I hope my voice is clear to you. So, is my voice clear? Anyone? Okay, so just let me know, is my voice clear? Am I audible to you? Then I will be starting the session. Okay, so I will be starting this session now. So let me introduce myself first. So my name is Himanshi Singh. I am currently pursuing PhD from Department of Mathematics, IIT Jodhpur, in broad area of probability and statistic. So I'm your TA for the course Essentials of Data Science with our software to Sampling Theory and Linear Regression Analysis, which is taught by Professor Shalab on the NPTEL portal or the SWAM portal. Okay, and every week I am conducting these sessions on every Monday. So this is the live session schedule. So from which we have already completed 4 live sessions, and today this is our fifth live session. And these sessions are conducted on every Monday from 6 to 8 p.m. Okay, and we have these links. So this first one is the Google Meet link from where you can get the link to join the live session every Monday. And the second one is the YouTube channel link. That is my YouTube channel where I'm uploading all the recordings and all the recordings of these live sessions. Apart from that, this is the third one is the Google Drive link where I'm uploading all the PowerPoint presentations and the R scripts for the tutorial and all the content which I'm discussing in this class. Okay. Okay, so the plan for the live session is we always follow that. First of all, I will be giving you a brief recap about the topic covered in a particular week. Then, if necessary, then I'll demonstrate some of the things in R. Then we will be doing some of the practice examples. That may be some calculative, theoretical, or which may include some R code or something like that. We will be discussing the practice examples, and then if you have any doubt or something regarding the previous lecture or these lectures or anything, if you want to ask, then you may ask at the end of the session. Okay. So now I will be starting the session. So first of all, I will be giving you a brief recap. So first of all, in the previous lectures, we were talking about how to first of all we were generating that how we can generate a sample from a population using R. Where we are talking about only the samples that are simple random samples. Okay, with replacement and without replacement, both were techniques we were discussing, and how we can generate samples by using the R code. We were discussing about that. Then in the previous lectures, we discussed about the sample mean and the population mean, and how we can estimate how we can estimate the population mean by using the sample which we have generated. Okay, and what can be the variance of those estimators when we are considering both of the techniques, that is whether it is with replacement, without a replacement. Here in all the examples, we are only considering that we are taking the sample using simple random sampling. Okay, not any other sampling. Okay, so this variance of the sample mean we have discussed. So here I have in the previous live session also I've discussed about these quantities, that what is this variance of y bar and what are the estimators. Here I've also included this slide because in the forthcoming uh, topics we will be using these variances. Okay, that's why I've included this in the slide. So now we will be discussing about the confidence interval. So basically, we have collected a sample. Okay, just wait a minute. Just give me 1 minute. Okay. Okay, so here, first of all, whenever we have taken out a sample, now from that sample, for example, let me explain it in a blank paper. So, for example, I have a population x1, x2 till xn. Okay, and now I'm interested in, for example, this is the population I'm talking about. Okay, now if I want to know that what is, so in order to measure the central tendency, we have already discussed that the sample mean, sorry, the population mean is used to measure the central tendency of the data. Okay, if we want to measure central tendency of the data, that where the center of the observations in the population lies, then that population mean is used to do that. And we have studied that sample mean, if we take the mean of these sample values, and sample mean okay, uh, behaves as an estimator for the population mean. Okay, and in fact it is an unbiased estimator of the population mean. Okay, so one of the estimate we can directly get from the sample mean, so that is a basically a point estimate for the population mean. Okay, so this is a point estimate. Okay, from the sample mean we get the point estimate. Okay, apart from this we also have a criteria that in order to estimate a parameter, apart from point estimate we also have a criteria or a concept, that is the confidence interval, CI. I'm writing it in a short form. So that is a confidence interval. So how to get a confidence interval for a sample mean? So that is basically is telling that the sample means that we are getting an interval. This is the lower limit, this is the upper value. And now basically confidence interval means that the sample mean, the probability that a sample mean lies in this interval is equals to 1 minus alpha percentage. Okay, that is there is 1 minus alpha percentage is the probability of, I can say there is 1 minus alpha probability that the my sample mean will lie in this confidence interval. Okay, so we call it as a 1 minus alpha percent confidence interval. Okay, so this is the probability of that probability that our sample mean x bar belongs to this confidence interval is 1 minus alpha. So this is basically the confidence interval. Okay, so we will be talking about this confidence interval. So we are now here, we will be majorly talking about confidence interval of the mean, confidence interval of the mean of population. Okay, we are not talking about variance or some other parameter. We are concerned about the mean of the population. Okay, so this is the background. Now here I have written directly that what will be the confidence interval. So here we are basically considering only the sample, because we do not know, have the knowledge of the total population. So we are basically considering a sample, and based on those samples I'm constructing a confidence interval for the population mean. Okay, that so this is the 100 into 1 minus alpha percent confidence interval of y bar, or I can say the population mean I'm saying. And this is, so here it is small y bar. Okay, if it is okay, fine, it is variance of y bar. This is y bar minus z alpha by 2 under root variance of y bar plus z alpha by 2 variance of y bar, if the population variance is known. So sigma square here is the population variance, and here we are considering the our random variables to be from the normal distribution with mu comma sigma square are the parameter, and I want to calculate the confidence interval for the mean. So this is the confidence interval if sigma square is known, and this is the confidence interval if sigma square is not known. The difference between the two is, here we are using z alpha by 2, z alpha by 2. Here we are using t alpha by 2, t alpha by 2. And in place of the variance of y bar, we are using the estimate of the variance of y bar. Because here when sigma square is known, we can calculate the variance of y bar also using this quantity sigma square. However, if sigma square is not known, we cannot calculate the this quantity using the population. So we have to take the estimate of this variance of y bar here. Okay, now what this z alpha by 2 and t alpha by 2 mean? So basically, if I consider a normal distribution, so let me explain it here. Okay, so if I consider a normal distribution, so the normal curve is like this. So z alpha by 2, this thing is the point. So it is a point on the x-axis, that is z alpha by 2, where on the right hand side, this area, the whole area is alpha by 2. Okay, so this right hand side area is alpha by 2, so this is that point. Okay, so this is z alpha by 2 is that point. Now if so here I have three quantities, y bar, z alpha by 2, and variance of y bar. T alpha by 2, this z, so if I consider this, so this is a normal curve. So this is a normal curve. If I consider the student t distribution, then T alpha by 2, because it is also have the similar kind of characteristics with normal. So if I consider the T distribution, then T alpha by 2 is the point where in the right hand side the area is again alpha by 2. Okay, so how to calculate? So these quantities can be calculated by using normal table, standard normal table, or the student distribution table. However, if I want to use the R language, then we can directly calculate this Z alpha by 2 by using this command Q norm 1 minus alpha by 2. Okay, and the quantity T alpha by 2 by using the command QT 1 minus alpha by 2 comma n minus 1, where n minus 1 is the degrees of freedom. Okay, now n is what? N is the sample size we are talking about. Fine. Apart from this, if we have the quantity small s square here, in these estimates, we have this quantity small s square. Now this small s square can directly be calculated by using this command variance of y. So if I have data y1, y2, yn is stored in a vector y, then I can directly write variance of y in order to calculate s square. So by using these codes, we can calculate these confidence interval. Now, how can we calculate? So I will be discussing those things in the practice examples. Okay, I've included all the examples. So here we have two conditions. So variance of y bar here is there. So the variance of y bar is different when we are considering simple random sampling with replacement, and it is different when we are considering without replacement. So we will use the variances accordingly. So if we are considering with replacement, then we will use this if the sigma square is known. If we are considering without replacement, then we will use this if sigma square is known. And similarly, we will use the estimates also if we want to use the estimates. Okay, so we will be using accordingly and finding out the confidence interval. Okay, now if I want to know the I want to know the population total. So for example, I have y1, y2 till yn. So this is the population, y capital N. So sometimes we want to know that what is the total. So if this is numeric quantity, this is numeric quantity, all are numeric quantities, and I want to know the sum. What is the sum? But so what will be that sum? So that is summation of yi going from 1 to n. Okay, so now this can also be written as n times of y bar, because 1 upon n, so this is y bar, so this can be written as n times of y bar. But when we cannot have the whole population and we want to estimate the total population, so we basically just replace the y bar, capital Y bar, by its estimator. So that is the small y bar, that is a sample mean basically. Okay, we can take, so this is an unbiased estimator of capital Y bar. So this total population total can be estimated by this quantity. So that is capital N into small y bar. So if I have a sample y1, y2 till yn, so I'll just calculate n times 1 upon n summation of yi, I going from 1 to small n. So that will be my estimate for the total population. Okay, so this is the estimate of the this is the estimator for the total population, which is an unbiased estimator. So basically expected value of this is equals to yt. So expected value of yt hat is equals to yt. So it is an unbiased estimator of yt, that is the total population. Fine. Now this yt hat is again a random variable. So how to calculate variance for this yt hat? So that is the variance of yt hat. So if we take variance of ny bar, so n square will come out and variance of y bar. Now for both the condition SRS WR and SRS WR, we have these quantities for the variance of y bar. We'll put it here and we'll get the expression, this type of expression. But we do not know about the whole population. That's why we want to estimate these quantities. So the estimator of variance of yt hat is these quantities. For SRSWR this quantity, and for SRSWR this quantity. So these are the estimate for the variance of YT hat. Okay, because in general we do not have the knowledge of the total population. When we do not have that, then we will use this estimator. And if we know the whole population or the quantities of the whole, for example the variance or something, then we will use these quantities. Okay, so this is about the estimation of the total population total. Okay, population total, we are talking about the sum of all the numeric entries. Okay, now here we have discussed about that when the random variable is measuring, or we are taking the sample where the entries are numeric. Okay, the population, the whole population where each of the random variable, each of the y1, y2, yn is a numeric entry. What if it is not numeric? So in place of the yi's to be numeric, we have some subjective answer. For example, if I want to collect a gender of people in a particular area, so I'll get the data in the form of male, female, others, whatever we are getting. So that is the next topic for it. So basically, if I want to know that in a particular area how many males are there and how many, so what is the proportion of male and female? Okay, how many males are there, how many females are there? Then first of all I'll go to the population. So what is my population? So the population will consist of the entries like male, female, and from there I will get a sample. And from that sample, if I want to do some statistics, some analysis, then how will I be able to do it? Because if I'm doing some statistics, then I need numbers. Without numbers I cannot do. So what will be the process then? So first of all, apart from this male female, also I can have for example, I give a fruit juice to the population, to the persons, and I want that I give five types of fruit juices. I want to know that what is the order in which they like the juices. So for example, they like apple juice at the so a particular person like the apple juice, the it is the best according to them, and then the orange juice, then the banana, maybe banana shake or something like that. So the ordering of that may be different for different people, and I collect the preferences of different people as a population, and I want to know that I want to know about certain things, that what is the majority of the population is liking. For example, what is the number of people which likes the apple juice the most, and all these things. So if I want to know these type of things, then what I should do in order to do the statistics, so that I can manage the to do the things mathematically. Okay, now for such kind of scenarios, if I have a sample which consists of the qualitative observations, then first of all, there is one technique where we just convert that qualitative random variable or qualitative sample to numeric. Okay. Uh, uh, so for example, if I have a sample like x1, x2, xn, where the answers of the people can be yes or no. So some yes are there, some no are there. Then we'll assign a number 1 to yes and number 0 to no. Okay, then we can do a further analysis. So we will be discussing about that in the forthcoming slides. Before that, here we are considering a particular scenario where we can divide the whole population in two classes. So for example, if I want to talk about gender and I'm only considering male and female, then I can divide the whole population into two parts, where one class is consisting of all the males, and second the other class is consisting of all the females, and they are mutually exclusive. There is no intersection in between them. Okay, so now if a scenario like this happens, apart from this also we can also have a different scenario like I give a fruit juice to different people, and I'll ask that whether they like it or not. Okay, whether so the answers will be whether they like it or they do not like it. Then also I have two classes, that whether people like that juice, and other class people do not like that juice. So now, so I can divide the whole population into two classes. So if such kind of scenario is happening, so basically I have two mutually exclusive classes from the whole population. For example, if I have class C and class C star, where class C consists of capital A units and class C star consists of capital N minus A units of the population. Okay, then the population proportion of class C will be the capital A by capital N. So this is the number of people which are agreeing to the fact which is present in the class C, and the population proportion of class C star will be 1 minus capital A by N, the remaining people. Okay, so these are the population proportions. So if now from that population of capital N units, I want to collect a sample of small n units. Now from that small n units, let small a be the those members or those units which are basically lying in class C, and so the small a by n will be the proportion, it will be the sample proportion of class C, and then 1 by 1 minus small a by small n is the sample proportion of class C star. Okay, so we can estimate this population proportion capital A by N by this sample proportion small a by N. Okay, now and how we are ensuring that it will be estimate, because we are collecting a sample in such a way so that it is representing the whole population. That's why we can use the small a by small n as an estimator of the population proportion. Okay, so as I discussed previously, that if the observations are qualitative, for example, gender, or for example, the answer says yes or no, okay, then what to do with the statistics? So we will here be considering this kind of scenario only, where we can divide the whole population into two classes. Now, in that scenario, I will convert the qualitative observations into a quantitative random variable. So basically, I have, so before I had this x1, x2, xn. Now I have y1, y2, yn, where this yi is 1 if the ith unit is in C. So for example, if x1 is in C, x1, x2 is in C star, so then y1 will be 1 and y2 will be 0. Such kind of. So now I have this random this sample which consists of the entries 1 or 0. Okay. Now in that case, what will be the population total? Population total will be capital A. So the number of so it will be the so the number of elements in the class C, that will be the population total. What will be the population mean? So population mean will be the proportion, the population proportion of class C, that is capital A by N. So sample mean will be the sample proportion of class C, that is small a by capital N. So sorry, it will be small n. Okay, small a by N. So that is the sample proportion. Okay, now apart from that, summation of yi square. So if I square this 1, so that will be 1 only. So that will be again be capital A, which is equals to np. Now by using this fact, I get that the capital S square is n upon n minus 1 pq, and small s square is n upon n minus 1 small pq. So this is the sample variance, and the so this capital S square is the small s square is the sample variance, and this capital S square is 1 upon n summation yi minus y bar whole 1 upon n minus 1 whole square, I going from 1 to n. So this is for the population. Okay, so this is the capital S square and this is the small s square. So this was about the sample, how to know the proportion of a particular class. Fine. Okay. Is it fine? Then we will move for the questions. If any one of you have any doubt, then tell me, just then I will be discussing that. Otherwise, we will start the questions. Okay, so if there is no doubt, then I'll start the questions. Okay, so the first question says that a sample of size 10 is drawn by simple random sampling with replacement from a population of very large size. So whatever the size of the population, we do not know. We know that the sample size is 10 and the sample observed sample is this. Okay. Now I want to compute a 90% confidence interval for the mean of the data. Assume that population variance is not known. So basically sigma square is not known. So sigma square is unknown. Fine. And the method by which we are collecting the sample is SRSWR, that is with replacement. Okay. Now the sample size is 10, small n is 10, and this is the data vector. So first of all, we have 90% confidence interval. So 1 minus alpha times 1 minus alpha is what? 0.90. Because it is, we want that 1 minus alpha 1 minus alpha percentage of 1 minus alpha into 100 percentage of confidence interval. So 1 minus alpha is 0.90. Fine. So so it is, so alpha is 1 minus 0.90, so it is 0.10. So this is my alpha. Fine. Why I want to calculate alpha? Because in the confidence interval, I need the quantity, this T alpha by 2 or Z alpha by 2. Okay, now since the population variance is unknown, so we will use the student's T distribution. Okay, so what is T alpha by 2, comma, n minus 1? So basically, what is alpha by 2? Alpha by 2 is 0.10 divided by 2, that is 0.05. 0.05. So this will be QT in the R, if I want to write it. So it is QT 1 minus alpha by 2, comma, n minus 1. So this is the R command. So this is the R command. I can also calculate it using the table, but it is quite easy to calculate using the R directly. So 1 minus alpha by 2 is 0.95. So this is QT 0.95, comma, what is n? 10. So n minus 1 is 9. So this is for this quantity you can calculate. Okay, now apart from this, I also want, so what is the basically the confidence interval is? So it is x bar, so which is the mean, plus minus T alpha by 2, n minus 1 variance of x bar. Okay, now since here we are considering SRSWR. Okay, we are considering SRSWR, so variance of x bar will be what? Now, we do not know about the population variance, so we will take the estimate of it. So what will be the estimate of variance of x bar? We know that it is small s square by n. We know it, okay? Because in the previous questions, we know that this is, with the replacement technique, it is s square by n, small s square by n. Okay? So it is small s square n by n. So how small s square can be calculated by using R? So it can be calculated by using the command. So this can be calculated using the command. So command for this is s square, only s square I'm talking about. So this is VAR of x, where x is this vector. Okay. And what is, in mathematically, what is the formula for s square? So it is 1 upon n minus 1 summation xi minus x bar whole square, where I is going from 1 to small n. Okay, so this variance, this estimate can be calculated. I know all the values of xi's. I can calculate the x bar, which is basically the mean of xi's. Then I can just put the values here of each xi and x bar and n, and I can calculate this quantity divided by n. So that will be the estimate for the variance of x bar. Okay. Fine. So let me show you. So this is basically x bar plus minus this quantity. So let me calculate all these quantities using R. We will do the calculation using R. So this is basically the random sorry, the sample. Okay. So let me show you this in R. So just a minute. So let me share it. So this is the So this is the question number one. So here I have taken this random this sample x. So I have stored this in x. So you can see here x is this the whole sample. So which I am doing it considering it here. Okay. Now x bar is mean of x. So what x bar is? I'll just run the command mean of x. Okay. So if I see, so what is x bar then? So what is x bar? X bar is 14.7. So directly I'm calculating from there. So x bar is, so by using the command, so x bar by using the command mean of x, okay, I'm getting it to be 14.7. So it is 14.7. Fine. Now, what is the next quantity? T alpha by 2 n minus 1. So what is T alpha by 2 n minus 1? I can calculate it by using the command qt. So what is it? 0.95 comma 9. So 0.95 comma 9. So what is the answer for it? So here it is qt 0.95 comma 9. I can see now this is 1.833. So I'll just take 1.833 here. 1.833. Fine. And again, then I have this quantity variance hat of x. So it is, sorry, it is square root of. So this is square root of variance of hat of x bar, and variance of x bar is s square by n. So how, first of all, I'll just calculate the variance hat of x bar. So which can be calculated, so which is basically s square by n. Now s square can be calculated using the command variance of x, so var of x divided by small n. Okay, so we'll see that what is the result. So here I've calculated v hat, so that is var of x divided by n. So you can see this is coming out. Okay, so n is not found. So variance of x, so v hat is, let me see, so v hat is 0.223. So it is 0.223. Okay, now I want square root. So let me, so this is basically the standard error. So that is equals to square root of variance of x bar, the variance hat. So that is equals to, so what is the square root of it? So here I have to see sqrt of v hat. So which is what? If I run it, so it is s underscore e. So this is 0.4725. So it is 0.472. Now I have all the quantities here. So the confidence interval will be x bar, that is 14.7 minus T alpha by 2. So this quantity 1.833 multiplied by 0.472. Okay. And in the right hand side, this is 14.7 plus 1.833 into 0.472. Okay, so this will be the confidence interval. Let me show you this. So here I have calculated, I have stored this in x bar minus this quantity in LCI and this in RCI. Then I have just calculated the confidence interval. So if I run it, You can see this, the confidence interval is 13.8337 comma 15.5662. So that is, so I can see it is 13.8337 comma 15.5662. 15.5662. So this is basically the confidence interval. So this is how we can get these confidence intervals. So I've explained it, the calculation which I am performing here, and I am performing using this R also. Okay, so by using R, this way we can find out the confidence interval. So I can run the whole code and I can get at the last the confidence interval for the mean. Okay, is there any doubt? No doubt. Okay, then we'll move for the next question. So here now, in the question, it is said that a population has known variance 16. So the population variance is 16. So basically the population variance is sigma square. Sigma square is given out to be 16. A sample of size 9 is drawn by SRSWR with replacement. So this N is 9 and we are considering the technique SRSWR. Fine. So now, okay. So the observed sample values are this, and I want to construct 95% confidence interval for the mean of the data. So since I want to construct 95% of confidence interval, so the alpha is, so 1 minus alpha is 0.95, which implies this alpha is 0.05. Okay. So alpha by 2 is 0.025. Okay, now since here sigma square is known, so we will be using the, so basically first let me write the confidence interval for it. So confidence interval will be, so it is x bar minus z alpha by 2 square root of variance of x bar. Now since here we know the population variance, so we do not want the estimate of it. We will use the variance of x bar only, and this is x bar plus z alpha by 2 square root of variance of x bar. Okay, now what is the variance of x bar first of all? So variance of x bar is, so what is the variance of x bar? So that is, if it is simple random sampling with replacement, then it is n minus 1 upon capital N. Small n is capital S square. Okay, which can also be written as sigma square by n. Okay, so here the variance of x bar is sigma square by n. So now, and z alpha by 2, z alpha by 2 will be, so z alpha by 2 now can be calculated using the command q norm. Okay, 1 minus alpha by 2. So what is 1 minus alpha by 2? So alpha by 2 is 0.025. So 1 minus alpha by 2 will be 0.975. So it is q norm 0.975. Fine. So now I know this z alpha by 2. Now variance of x bar is sigma square by n. So it is sigma square by n. So what is sigma square? So the sigma square is 16. So it is 16 by n is 9. Okay, so I know the variance of x bar, that is 16 by 9. I know z alpha by 2. How x bar is calculated? So x bar will be calculated by using the command mean of x. Okay, so let me write these using R first of all. So what is q norm 0.975 and x bar? So here I've taken this vector x. Let me run it. Now what x bar is? So x bar is 19.666. So it is 19.666. So this is the sample mean 667. Okay, now what is z alpha by 2? Z alpha by 2 is this q norm 0.975. So let me see. So what is z alpha by 2? So it is 1.959. So we can write it as 1.96 here as an approximation. Fine, I know x bar, I know z alpha by 2. What is variance of x bar is 16 by 9 and under root of 16 by 9 is 4 by 3. So we'll just place it here. So confidence interval will be x bar, that is 19.67, I am right. Okay, minus z alpha by 2, that is 1.96 multiplied by, so this is this multiplication multiplied by this 4 by 3, I can say. This comma 19.67 plus 1.96 plus 1.96 multiplied by 4 by 3. So this will be the confidence interval. Let us see what is the answer in our R if I do it. So I just stored those values in LCI and RCI and just printed those values. So let me see it here. So if I do it, so the confidence interval is 17.053, 22.279. Okay, so it is 17.053, comma 22.279. 22.27. So this is the confidence interval. I hope it is clear that why we are using Z alpha by 2. So this is basically, these all things are governing by our formulas. And we are basically using the technique here for this question. This is simple random sampling with replacement. Is it fine? Is there any doubt in this? If someone want to ask anything, you may ask. So if there is no doubt, then I'll move forward for the next question then. Okay, so if there is no doubt, then let's move for the next question. So now here in the next question, we are considering a finite population has size 100 and known population variance 25. So here we know the population variance sigma squared again to be known as 25. Now a sample and capital N, that is the population size, so that is 100. Then a sample of size 16 is drawn. So here I am taking the sample size N to be 16. Is drawn using the technique simple random sampling without replacement. Okay. Now the observed values are given. The observed values of the samples are given. Now construct a 99% confidence interval for the mean. I want to construct a 99% confidence interval. Okay. Now 99% confidence interval means that 1 minus alpha is 0.99, which implies that alpha is 0.01. Okay, which implies that alpha by 2 is 0.005. Okay, which implies that 1 minus alpha by 2 is 0.995. Why I'm calculating 1 minus alpha by 2? Because that will be helpful in calculating the quantile point. Okay, so this is 1 minus alpha by 2. So what will be, first of all, the confidence interval for it? So that will be x bar minus, so since we have the known population variance, so here it will be z alpha by 2 and under root of, and since it is known, so it will be variance of x bar, not the estimate, only the variance of x bar, and this is x bar plus z alpha by 2, z alpha by 2 square root of variance of x bar. Here this is not the estimate, we are taking the variance of x bar. So first of all, x bar will be calculated using the mean. Z alpha by 2 can be calculated using a q norm command. Now what will be the variance of x bar? So variance of x bar. So for the simple random sampling, for the simple random sample without replacement, what is the variance? So it is n minus n divided by capital N into n s square. Okay, now but s square is not known. Okay, so s square is not known, so we know that the value of sigma square. We know the value of sigma square, that is 25. We do not know what is capital S square. So but we know the relation that 1 upon capital N minus 1 summation I going from 1 to capital N yi, or I can say xi minus x bar whole square. So this basically is capital S square, and 1 upon capital N summation I going from 1 to n xi minus x bar whole square is sigma square. These two quantities we know. Okay, this is one. So this is one. This is two. Now from 1 and 2, I know that summation xi minus x bar whole square is equals to, from 1 what I have, n minus 1 s square. So this is n minus 1 s square, and from the second one I know that this is n into sigma square, n into sigma square. So what I get, I got this relation, that n minus 1 s square. So here we are using the capital S square. Okay, so n minus capital 1 s square is equals to capital N s sigma square. So from here what I get, so I got 1 minus 1 s square is equals to n into sigma square. So which implies s square is n upon n minus 1 into sigma square. Fine. So this is s square. Now I want to calculate the variance of x bar in terms of sigma square. So what it will be? So variance of x bar is equals to what it is? It is n minus n divided by nn. So n minus n divided by n into n multiplied by capital S square. So that I write in this form. So that is capital N upon capital N minus 1 into sigma square. This n will get cancelled. So it is capital N minus n upon n minus 1 sigma square by n. Okay, so this is the variance of x bar in terms of sigma square. Fine. Now I know what is sigma square, I know what is capital N, what is small n. So I'll just place the value in order to calculate the variance of x bar. So that is capital N is 100. That is 100 minus small n is 20, small n is 16. Okay, 100 minus 1 is 99 multiplied by sigma square by n. What is sigma square is 25 by 16. So that will be the variance of x bar. That can be calculated. We can just code it in R and we can just calculate it. Okay. So let me further proceed. So, okay. So now I have this to be the confidence interval. So the confidence interval will be, so now what is x bar? What will be, so first of all, let us consider what is x bar. So that is mean of x. Okay, by using this command I can get it. So here this is the vector. So I have just coded it in R. So here I have this x to be this vector. Okay, and x bar will be mean of x. So let us see what x bar is. So x bar is 33.5. So here I can write it is 33.5. Okay. Now what is the next quantity? X bar we have calculated z alpha by 2. So now z alpha by 2 can be calculated using the, so z alpha by 2 can be calculated using the command q norm 1 minus alpha by 2. So 1 minus alpha by 2 is 0.995. So 0.995. Okay. So what is z alpha by 2? Here, so by using the command q norm 0.995, what I get, so let me show that in R. So q norm 0.995, here this is the value. So here it came out to be 2.5758. So let me write it as 2.58. Okay. So this is Z alpha by 2. Okay, what is the next quantity? That is the square root of variance of x bar. So variance of x bar is this. I can just take the square root of this. So that will be the variance of x bar. So variance of x bar is equals to, so this XQRT of this quantity. So let me, so if I have assigned this variance of x bar as here, for example, V, okay, in R, so it will be SQRT of V. So V is this quantity, this one. Okay, in R I just coded by using this division and multiplication. So let me write. So V can be like, V will be this n minus n divided by n minus 1. So this is n minus n divided by n minus 1. In R, we are calculating star n here, and the whole star is sigma square. If I'm like, whatever it is, in place of this, you can also write 25. Okay, which is the sigma square value. This one. Fine. So this will be calculated. So the confidence interval will be. So confidence interval will be, let me calculate. So in R, what I've done, I've just calculated this V, what is the quantity. So it is n minus 1 divided by n into n minus 1 into sigma square. And sigma square is 25. So here, so this quantity V, so this is E, so this is coming out to be 1.3257. So it is coming out to be 1.3257. Okay. Then we have square root of it. So that is a standard error. So standard error, standard deviation. So this is 1.151. So this is the square root of this is coming out to be. So this is coming out to be 1.151. This is 1.151. Now using all these things, so here this will be 33.5 minus 2.58 multiplied by 1.151, comma, what it will be 33.5 plus 2.58 multiplied by 1.151. Okay, so this will be the confidence interval. So I can see this using this command in R. So if I run it, I got this confidence interval, that is 30.5341, comma 36.4658. Okay, so this is coming out to be 30.5341, comma 36.465. Right? So this is the confidence interval. Fine. So basically, we are using the methodology or the theoretical results from the statistics, and we are using all the computation calculation, all those things by using the R software. Okay. Is there any doubt in this question? Okay. So then we'll move further. So we have basically considered 3 questions till now. Okay, in the first question, I took this simple random sampling with replacement technique where the variance was unknown. In the second question, I took simple random sampling with replacement again with known variance. Here in this question, I took simple random sampling without replacement with known variance. Now I will be taking in the next question simple random sampling without replacement when the variance is not known. Okay, so here in the question, let us see that a finite population of size 40 is given. A sample of size small n is equals to 6 is drawn by simple random sampling without replacement. Okay, so first of all, the capital N is 40 and small n is 6, and the technique is simple random sampling without replacement. Now the observed sample values are, so this is the sample values, and I want to construct 95% confidence interval. Now since I want to construct 95% confidence interval, so 1 minus alpha is 0.95, which implies alpha is 0.05, which implies alpha by 2 is 0.025, and which implies 1 minus alpha by 2 is 0.975. So 1 minus alpha by 2 is of interest because we want to calculate that quantile point by using the command. Okay, so that's why I've calculated 1 minus alpha by 2 before it. Now what is the confidence interval for it? So confidence interval for it will be x bar minus, since the population variance is not known in this question, so we will use the t distribution. So this is t alpha by 2, okay, and here square root of variance of x bar, and since the population variance is not known, so we will be taking the estimate of it, okay, comma x bar plus t alpha by 2 under root variance of x bar hat. Fine. So this is the variance of x bar hat. Sorry, this will be capital X. Okay. Now we know x bar, so x bar can be calculated using the mean command. So x bar will be mean of x. So first of all, let us see that what x bar is. So here in the next question, I've calculated, I've taken this value and calculated x bar. So what x bar is, let us see. X bar is 4.5. So this is 4.5. Fine. What is the next quantity? Next quantity is T alpha by 2. What is T alpha by 2? So as I've discussed, T alpha by 2 can be calculated using the command Qt, okay, 1 minus alpha by 2, comma, n minus 1. So which is basically Qt. What is 1 minus alpha by 2? So this is 0.975. Small n is 6, so small n minus 1 will be 5. So it is 0.975, comma 5. So in R, if we calculate it, so what it is? So here I've calculated it. So it is small t is 2.57. Okay. So it is 2.57. Okay. Now, okay. So now this is square root of variance hat of x bar. So first of all, let us calculate what is variance of x bar. When we are using this simple random sampling without replacement, variance of x bar is without replacement is n minus n upon n into n capital S square, and the estimator of it is, if I want to calculate the estimator, so this is n minus n upon n into n small s square. Okay. Now small s square can be calculated using the command variance var of x. Okay. So this can be calculated using this command. So let us first see what is this s square. So this is var of x. So if using r, if I want to know that var of x is 3.5. Okay. So this is 3.5. And what is this variance using this command? N minus n divided by nn. So here you can see v hat is n minus n divided by n multiplied by variance of x. So what is v hat? So if I want to see that, so v hat is 0.13125. So this v hat is 0.13125. 13125. Okay. Okay, but in the here I want square root of it. Okay, so the standard error I can say, so that is the square root of variance of x bar hat. So what it is? So this will be the SQRT of this quantity. So here I have calculated using R SQRT of V hat. So that is 0.3622. Okay, so this is 0.3622. Fine, now I have calculated all the quantities. Now I will just put it in the confidence interval. So confidence interval will be x bar. So what is x bar? 4.5. 4.5 minus this T alpha by 2. So T alpha by 2 is this quantity 2.57. So this is 2.57 multiplied by square root quantity, that is square root of this quantity, this whole quantity. So this is 0.3622. Okay, so 0.3622, and the right side will be 4.5 plus 2.57 multiplied by 0.3622. Fine. So the confidence interval, if I use R, then it will be, so here I've calculated the LCI, RCI, I just printed it. So if I do that, so what is this? So it is 3.568, comma 5.431. So it is 3.568, comma 5.431. So this is the confidence interval. Okay, is it fine? Any doubt? Any doubt in this question? Here I can run the whole and I can get, okay, sorry, there is some mistake. So if I run the whole thing, actually some of the variable was assigning a different value from the previous command. That's why I'm getting the different one. So okay, so this is not correct. So let me correct it. Okay, so it is coming out to be 2.689. Okay, and 6.310. Because previously some variable was assigned a different value, that's why. So let me recheck other ones also once. So this confidence interval is coming out to be 13.83, 15.56. So it is, yeah, so it is correct. But the next one, 17.05, 22 point something. So yeah, it is also correct. Okay, third one, because I have assigned the same name to the variables. So that's why there may be a mistake. So 30.53, 36.47. Okay, others are correct. So this one, 2.68 and 6.31. Now it's correct. Fine. You may do one thing, that you may just do the calculation by yourself by hand once, and then just do it by hour, and you can just check whether the calculation using the R and the calculation which you are using both are same or not, in order to check that what basically R is doing. Okay, so is it fine, this question, these type of questions, this confidence interval? I discussed all four types of confidence interval questions. Okay, so then we'll move forward for the next question. Okay, so here now, as I discussed before, that the sample or the population, the variable is like we are taking variable which are not having a numerical observations. Okay, so the observations is some qualitative observations like yes or no, male or female, or some kind of this thing which we for which we cannot do some kind of multiplication addition. So basically, the numeric entries are not there. Okay, now this is a question on such kind of scenarios. So the question says that a sample of 75 consumers was selected by simple random sampling without replacement from a town to assess the quality of a packaged food item. Okay, so a sample of 75 consumers was selected. There were many people, but from those many people, only 75 observations are taken. Okay, now if each consumer was asked that you want to rate the item as the item is acceptable or not acceptable. Okay, so the consumers will give you the answer that whether the item is acceptable or not acceptable. So okay, so then we can see here that we can divide the whole population into two classes, where one class is representing that the item is acceptable. All those consumers are in one class where the items are acceptable, or some item, the food item is acceptable, and other class is the class where the people says that the number of people, or the people which are saying that the item is not acceptable. Okay, so we divide the whole population in the two parts, and both the parts are mutually exclusive. That implies that both the population, both the classes cannot have any intersecting point. So there cannot be any consumer which can say that the item is acceptable and non-acceptable both. So no consumer can say that. Okay, So now this is the scenario. So this is the population. First of all, population is such kind of population, and now we have drawn a sample from of that population of 75 consumers. Okay. Now the responses are stored in a vector rating. So the responses of all the consumers is stored in a vector. Okay. So here I have not written that because this is of length 75, and writing that vector is very much messy will be here. So I have just created that vector in R. So you can just see that this is a rating sample. So this is the sample observations of acceptable, non-acceptable from from different consumers, and I've stored all the answers uh, in this variable. Okay, so you can see this is a variable. So let me run it. So this is now my sample. Okay, so that is rating underscore sample. You can just see, so this is now my so here I have this vector, okay, which consists of what entries, character entries. Okay, now if I consider this as a sample, I cannot perform any type of calculation. Fine. Now, what should I do? So, previously, which I've discussed, that in order to do some statistics, so in this question also it is asked that define the estimator of the population proportion of consumers who find the product acceptable and compute the estimate. So basically, they want to know that what is the estimate of the population proportion of those consumers who are saying that the product is acceptable. So how much of the population, what is the proportion of that population, which what is that proportion of the population which is saying that the product is acceptable. Okay. Okay, if the proportion is 0.5, then you will say, okay, half population is saying that the product is acceptable and half is saying it is not. If the proportion is 0. For example, 85, then you are saying, okay, the most of the population is saying, most of the people is saying that the product is acceptable, and there are less number of people who are saying the product is not acceptable. So by knowing the proportion, you are basically inferring that whether what is the majority of people are saying regarding this product. Okay, so for that, first of all, I want to define an estimator of the population proportion of the consumers who find the product acceptable. So basically, I will consider this class C to be the class to be the class of those consumers which are saying that the product is acceptable. So it is the consumers which says that the product is acceptable. Okay. Now, if I'm considering this class and I want to know the proportion of these people, or I want to construct an estimator, so first of all, I will convert. So this is the class here. Okay, and also I'll write here that x1, x2. Okay, so this is capital Xn. So here it is basically the qualitative observations. Okay, the qualitative observations basically, so which basically states that the product is acceptable, not acceptable, and all those things. Okay, now from this I will make a quantitative observations. How I will make? So I will construct yi's such that each yi is 1. Okay, if ith person says acceptable. Okay, or I can say if ith person is in class C, fine, and it is 0 if ith person says not acceptable. Okay, I'm constructing yi's in such a way. Okay, here mathematically I have written it. How to make this in R, I will be discussing first. So if I want to construct a vector y, okay, so which is giving 1 if it is acceptable and 0 if it is not acceptable. So there is so y will be a vector. So I can use this if else. So in R, this if else is used. Okay, so if else is a command which is used to basically if I write if else, and this is So this was a vector. What was the vector I have taken? So that was a rating sample. So here I have taken this to be a rating sample. So if else rating underscore sample. So basically I'm taking rating sample to be the values which is stored in. If rating sample is equals to acceptable, comma. So basically if else command what do? So it basically goes to the first argument. If this condition is true, then it will give that value to be the, so if I write 1 and 0, so what it will do, if this is true, then it will display this quantity. If it is false, if this condition is false, then it will display this quantity. Okay, so it basically construct a random variable, so sorry, a sample, which now y will be a sample kind of 1 0 0 1, this kind of a sample. Okay, so let me show that. So here x is if else. So here okay, so it is rating underscore sample. Okay, so now here I have taken it to be x. So this kind of variable is constructed. So I have constructed a quantitative variable now. Okay. Now I want to I want to define the estimator of the population proportion. So if this y1, y2, yn is the population, okay. If y1, so this is basically the sample I'm constructing. Okay, if I would have known the whole population, so if y1, y2, yn is the population, okay, so what will be the estimator for the proportion of the acceptable thing? So it is 1 at each position, so it will be what? So the estimator will be, so the estimator will be what? So it will be 1 up. So I want to know the population proportion, so it will be 1 upon n summation of yi going from 1 to capital N. So this will tell me, so because 1 are there on the positions where there is acceptable thing. So all the total number of consumers which are saying acceptable, we will be getting using summation of yi, and we are dividing that with the whole number of the population, that is capital N. So this will give me the population proportion. Okay, so this will give me the population proportion. Okay, but I want estimator. Okay, so this is not the estimator, so this is the population proportion. But if I want the estimator of it, because I do not know the whole population, but if I want the estimator of it, so then what will be the estimator? So estimator of population proportion. So what will be the estimator for it? What will be the estimator? So what basically it is? So it is the total population divided by capital N. So if I say, so this is the total population divided by capital N. If I take the sample, so from the sample only I want the estimator. Okay, so I have to take summation of yi, I going from 1 to small n and 1 by n. Okay, so basically the population, the estimator of population proportion is sample proportion. So sample proportion, which is equals to 1 upon n summation yi, I going from 1 to n, okay, is the estimator of population proportion. See, here I have certain kind of scenario that the summation yi is giving me that what is the total number of consumers which are saying acceptable, because I have the random variable as 1010. That's why. But if there are some different numbers, then this may not give you the sample proportion. Okay, then this may be different, but because I am assigning this kind of scenario, that's why I'm able to say that this is the sample proportion. Okay, so now this is what basically, this is the mean of the x. So here if I say, so the p hat will be the estimator of the population proportion would be the mean of x. So if I calculate that, so that is, so this is 0.72. So this is coming out to be for this. So in the second, so it is basically asking that what is the estimator. So estimator will be this. So this is the estimator basically. And what will be the estimate? So estimate will be so mean of. So if this is y, then mean of y. And in the arc, I have calculated, I have named it as x. So that's why I have written as mean of x. So it is 0.72. Okay, so small y I should write. Okay, is it fine? Is it fine? Okay, then we'll move for the next question. Okay, so here we are considering that the population is very large and a sample of size 10 is drawn by using simple random sampling with replacement. Okay, now the observed sample values are given in this vector y. Now I want to estimate the total population assuming that the population size is 500. So basically I'm saying that y1, y2 dash dash y 500. So this is basically the population. Okay, now I want to estimate the population total. So what basically population total? So let me represent it by pt. So this is the population total. So basically these are the numeric quantities and I want to sum them up and I want to, so this is basically, this is the population total where I going from 1 to 500. Now, because I do not know the values of the variables for whole population, so I want to estimate this now. Okay, so first of all, I can write it as n times of y bar. Is there an issue? Because y bar is what? 1 upon n summation of yi going from 1 to n. So from here, n goes here and summation of yi is n of y bar. That is fine. Okay, now I want to estimate PT hat. I want to estimate PT. So PT hat, I want to know. So this capital N will be, because this is so known, I can have this is the population size. Now Y bar, for Y bar, I need to know each and every value. Okay, so if I want to estimate this Y bar by this sample, so I know that small Y bar is the unbiased estimator of capital Y bar. So I will use this Y bar here. Okay, so this PT hat, so this is an estimator of PT. Okay, in fact, it is an unbiased estimator. For example, if I take expected value of PT hat, so that is expected value of n times of capital Y bar. Okay, so this is n will come outside and expected value of capital Y bar. Okay, so now n times expected value of capital Y bar. So that is n times expected value of 1 upon n summation yi. Okay, so it is n times expected value of 1 upon n summation yi. So this will be what? N times of expected value of yi. So n will get cancelled and it will be the expected value of yi. Okay, so this will be n into, okay, sorry. It is small y bar. So it is small y bar. I'm talking about the estimator. So this is small y bar. So this is small y bar. Okay. So here it is small y bar. And we know that the small, and we know that the y bar is unbiased estimator of capital Y bar. Okay, we have learned it already. So expected value of small y bar is capital Y bar. Okay, so this we know. So which implies expected value of PT hat is equals to n times Y bar, which is PT hat. So what it shows? What it shows that PT hat is unbiased estimator of, not PT hat, so it is PT. Fine. So basically, so this was an extra information. Basically, in this question, it is asked that I want to estimate the population total. So this basically is the estimator for the population total, and I want to estimate it. Then I will just put the values here of the sample. So PT hat will be, so if I want to calculate it using R, so it will be capital N star. So what is Y bar? So it is Y bar, and it is stored in Y. So it is mean of Y. So this is mean of Y. Okay, so this is the command, R command. So if I run it in R, so here you can see, here I have assigned the values of capital N, small n. So the estimate of the population total is N star mean of Y, which is basically this N star mean of Y. So here if I run it, so here you can see the estimate of population total is 14150. Okay, so it is 14150. Fine. So this is the estimate of the population total. Okay, now in the next part, it is asked estimate the variance of the estimator. Okay, so variance of the estimator, this estimator. So variance of PT hat. So what is the variance of PT hat? So that is variance of n times of small y bar. Okay, so this is the variance. So this n square will come out because outside the variance, if there is some constant, it comes out as the square. So a n square variance of y bar. Okay, now variance of y bar depends upon whether the technique is simple random sampling with replacement or without replacement. Let us see. So it is with replacement. So here we want to calculate it with replacement. So it is n square into, so what is the with replacement thing? So it is n minus 1 divided by n into n to s square. Okay, so this is the variance of PT hat. Now, since in the question we do not know about the population variance, so we do not know this quantity. So I want to estimate this variance. So what will be the estimator? So let us again consider the estimator. So in fact, this can also be written as, so this n minus 1 upon n s square is sigma square. So it is n square sigma square by n, and we do not know this. So the estimator for this can be, so the variance hat of PT hat. So this is, so we have studied before only that so since n square and n is known, only I need the estimator of this sigma square. So small s square is an unbiased estimator of sigma square when we are considering simple random sampling with replacement. So the estimator will be n square small s square by n. Okay, so this will be the variance, the estimator of the variance of PT hat. Okay, so if I want to estimate it, so what I will use? I'll use the command n to the power 2 asterisk s square can be calculated using the command var. So var of what? So the random variable, so the sample vector is y. So var of y. Okay, the whole thing is divided by small n. Okay, so here you can see in the r, I have written that only n square by n var of y. So here if I see, so the estimate of variance is 89166.66. Okay, so it is like, I can say that it is 89167. So that is approximately 89167. Is it fine? Is it fine? Any doubt in this question? The population, so basically we are finding out the estimate of the population total and variance of the estimator. Estimate of variance of the estimator. Is it fine? I just coded these formulas here only. Okay, second part you want to, okay, so basically I want here in the question estimate the variance of the estimator. Okay, so first of all, what is the variance of the estimator? I have calculated here. So the estimator is PT hat. Okay, I want to calculate its variance. So variance of PT hat will be variance of what PT hat is, n into y bar, small y bar. So this is n into small y bar. So if I take n outside, because n the constant, so n will come outside as n square. Okay, so n square variance of y bar. Now I'm considering the technique that simple random sampling with replacement. If I consider simple random sampling with replacement, then variance of y bar is given as n minus 1 upon n s square, and n square is as it is. So it is n square into n minus 1 upon n s capital S square. So that is basically the variance of y bar, which we have studied in the last class only. Fine. Now this n minus 1 upon n and s square, this in place of this, we can also write sigma square by n. Why? Because we have this relation that n minus 1 s square is equals to n of sigma square. I have proved it in one of the example. You can see that. So this n minus 1 capital S square is equals to n into sigma square. By using this relation, I have written this. Capital N square sigma square by n. So this is basically the variance of PT hat. But in the question, if you see, so there is no population variance is given. However, this sigma square is the population variance. So we had to estimate that what is the variance of PT hat. We need to find out the estimate. In the question also it is written that estimate the variance of the estimator. So basically variance of the estimator is this thing, but since we do not have the knowledge of sigma square, so we will estimate this quantity. Now this quantity is n square by n. So these are the constant. So we can write it directly. But s square, the small s square, this small s square is an unbiased estimator of sigma square under the technique simple random sampling with replacement. This also we have studied. So in simple random sampling with replacement, small s square is an unbiased estimator of sigma square. So in order to estimate this whole quantity, I can just replace sigma square by small s square in order to estimate this quantity. Okay, so just I have used this n square small s square by n, variance of PT hat, the estimate of the variance of PT hat. So this formula is directly given. So in the class also this formula was given. I've just explained the steps by which this is coming. Okay, so this is n square small s square by n. So this came out to be the variance, the estimate of the variance of the PT hat. Okay, now this capital N square we know. So this is capital N is 500. So I can just square it. Small n is I know that small n is 10. So I can just know it. But small s square is what? So small s square can be directly be calculated using the R command VAR of y. So if y is a random vector consisting of sample, then VAR of y will give me s square, small s square, which is nothing but 1 upon n minus 1 summation of yi minus y bar whole square. This you can calculate by hand also, but in R, there is a direct command in order to calculate this quantity, which is VAR of y. So I've just used the command n to the power 2 star VAR of y divided by n, small n. I just calculated this variance in R. Now is it fine? Okay. Okay, so this question is also done. So we have now in this question discussed about the estimation of the total population total and the estimate of the variance of that estimator of the population total. Okay, so we'll move for the next question. Okay, so here in this question again, here what is the difference that in the previous question we considered simple random sampling with replacement. Now this question is also a similar type of question, but here we are considering simple random sampling without replacement. So the change will be there in this variance because we are considering the different technique. So here variance of y bar under with replacement was different. Now in the next question it will be different because we are considering the simple random sampling without replacement. So let's see that. So first of all, I want to estimate the population total. So that will be simple. So that will be the same. So if I want to estimate the PT hat, so PT hat I know that it is basically the capital N of y bar. So there is no change in it. For both the technique, it will be same. Okay, because there is a no option of the variance of y bar here because we are only just having the estimate of capital Y bar, which is small y bar, and we are done with it. So it will be what? So in R, if I write, so it will be capital N star mean of y. So basically y, in y these values are stored, and I can just write capital N into mean of y. So it will give me the estimate of the population total. So let me show you. So this is the question number 7. I have stored these values in y, and here I've just written the code. So here it is giving me the estimate of the population total is 3000. Okay, so it is giving me, so this is coming out to be 3000. Okay, now what about the second one? So if I consider the B part, so I want to estimate the variance of the estimate of the population total. Okay, so I want the variance of PT hat first of all. So that will be n square variance of y bar. Okay, now here we are considering simple random sampling without replacement. Now for without replacement, we have a different formula. So that is n square into, so this is n minus n upon n into n capital S square. So this is the variance of PT hat. Okay, variance of PT hat. So that is capital N square n minus n upon n into n capital S square. Now in the question, we only have the knowledge about the sample. We do not know what is the variance of the population. Okay, so we basically don't know this quantity capital S square because it is dependent upon the whole population. So I need to estimate this, as it is written on the question also, estimate the variance. Okay, so I need to estimate it. I need to find out the estimate. So what will be the variance of PT hat, estimate of it? Okay, so here you can see this is capital S square, and under SRSWOR we have studied that small s square. So small s square is an unbiased estimator of capital S square under SRSWOR. Okay, so this is the thing. So we'll just use, in place of capital S square, we'll use small s square. This we have studied in the previous class. Okay, so it will be n into n minus n into small s square by n. I've just taken this out. Okay, so this will be the quantity. Okay, now this will be like n in R. If I want to write n star n minus n star, so this is s square. So that can be calculated by VAR, the command VAR of what is the variable, what is the vector name, y, VAR of y, and the whole thing is divided by small n. So here you can see the formula is changed. Here the formula was n square s square by n, but here in SRSWOR we have n into n minus 1 s square by n. Okay, so accordingly we have coded it. So in the code also I have done that n star n minus n by small n star n minus n by small n into variance of y. So if I run it for this, that I'm getting, the variance of y is 25733.3. So it is 25733.33. So this will be the estimate of the variance of PT hat. Is it fine? So these formulas are given. These formula I have just derived it using the previous results. These formulas are also discussed in the week 5 lectures. Is it fine? Is this question and the formulas are fine, or is there any doubt? Okay. Okay, so this is done. So we'll move for the next question then. So this is the question 8th. Okay, so here in the question it is written, the variance of an estimator of population total under SRSWR WOR includes a finite population correction. Okay, so we have discussed about previously the finite population correction. What is finite population correction? That is n minus n upon capital N. So this was the quantity which is known as finite population correction, FPC. So it is basically asking that the variance of estimator of population total under SRSWR includes a finite population correction. Okay, so whether this statement is correct or not, first of all let me show you. So basically it is asking variance of the estimator of population total. So what is estimator of population total? That is PT hat. Okay, so that is basically we have discussed that this is n into y bar. Okay, now variance is what? So variance of PT hat is n square variance of y bar, and they want it under SRSWOR. So since we have calculated it already, so this is what in the without replacement, this is n minus n upon n into s square. Okay, so here you can see n minus n upon n is there, s square by n, and this is this capital N square is there, and n minus n upon capital N is there, and this is n, and this is n square here. Okay, so we have, yes, we have this population correction factor. Sorry, finite population correction for this also. Okay, so since when we are considering simple random sampling without a replacement, in there also there was a finite population correction. So here also it arises. Okay, so yes, so the answer is yes. So the answer to this question is yes. This consists of finite population correction here. Okay, so which basically means that if the capital N is very large, okay, so then we can basically neglect this factor and we can just use this. So if capital N is large, then this factor can be neglected. How? Because this factor basically means 1 minus small n by capital N. So so if capital N is large, this will go to 0. This is 1. So basically we can neglect this. So this quantity will be approximately equal to n square by s square by n. So this basically means that this is a finite population correction. So if the population is finite, or I can say the population is 40, 30, 100 also, then we can just use this. But if the population is very large, for example, 1000, okay, then in that case, this quantity will be nearly 0, and 1 minus this quantity will be nearly 1. That's why we can just remove this quantity, and we can just find out this value, capital N square s square by n. Then it will give us the estimate for the variance. Okay, because this is not having that much of influence if capital N is very large. So that basically the meaning of finite population correction. Okay, is it fine? So the answer to this question is yes, and the reason I have just proved it. Okay. So the next question. So this is ninth question. So the estimator of population total under SRSWOR has a smaller variance than under SRSWOR. So let us see. So estimator of population total. So for the SRSWR, first of all. So what is the population total is PT, and the estimator is PT hat. So that is basically Y bar to capital N. Okay. Now the estimator of population total is this. Now first of all, take the variance of n into y bar. So this is basically n square. Now here I am taking SRSWR with replacement. So variance of y bar will be n minus 1 upon n into n capital S square. Okay. And variance of n into y bar. So here I am taking with replacement. Here I am taking without replacement. So this is n square into this is n minus n upon n into s square. Okay. Now if I write this, so if I write this, so it is n square so what I can write here. So this quantity, just forget about it, this quantity. So this quantity n will get cancelled. Okay, now if I multiply this quantity, so it is n square by n. Okay, so this is n square by n s square. Okay, plus or minus, sorry. minus n into s square. Okay, here if I do it, so here this will get cancelled. Okay, so this is n square by n, not n, small n, s square, okay, minus capital N by n s square. Fine, and then what I can say, so here let me write it WR, let me write it WOR. Fine, now I can just find out this quantity, so it is variance of n y bar WR plus n s square is equals to n square by n s square. Now from here, this quantity is this variance plus this. Okay, so in the next slide, so variance of n into y bar WR plus n s square is equals to, this quantity I'll write it from this. So it is variance of n y bar WR, okay, this plus n by n s square plus n by n. Okay, now just let me take it there. So variance of ny bar WR minus variance of ny bar WR. So if I take this quantity there and this quantity here, so it is n s square minus n by n s square. So this is n minus n by n s square. Obviously this quantity is smaller, so this difference will be always be greater than 0. So this is greater than 0, so which implies variance of n y bar under WR is greater than variance of n y bar under WR. So basically what in the question what is said, that the variance under SRSWR is smaller. So under SRSWR it is greater. So the answer to this is no. And we have calculated, we have given the reason that why it is no. Okay. Yeah, what we have done, we have just calculated both the expressions. We know that okay, fine, this quantity and this quantity is same for both of them. So we just taken out this quantity from this and just placed it here and compared it, find out that the difference of them is greater than 0. So this quantity is greater than this quantity. Okay, so is it fine? How we have done it? We have just used these two equations, this and this. Okay, fine. So these were the questions I have for today. Now, this is for your information that recording of this session I will be uploading on YouTube. Presentations and the R script will be added to Google Drive. And deadline for your assignment is 25th of February. And our week 6 lecture or week 6 session will be on 2nd March. Okay. Now, if you have any doubt, then you may ask. Okay. So if there is no doubt, so I'm just okay. So if no doubt, then there is no problem. I was if you are understanding or not, just let me know that whether the things are clear or not, because I am just wanting you to understand each and everything in a detailed way. I wanted the class to be a little more interactive, but there are less people, so the class is not that interactive. we cannot do anything with that. So I hope the things are clear. Okay. Okay, then if okay, so yeah, then we can just end this session. And I want to thank you for joining, for having patience. Okay, and we'll meet in the next session on 2nd March. Okay, I hope that you just go through the lectures, the week 6 lectures, and we will be discussing some of the practice questions and the concept in next class. Okay. Okay. Thank you. Then we'll end the session.